All right, when we left off, we had just made these tables and kind of found the inverses of them, and the inverse of the function is actually what we're interested in. We're interested in these cube root functions and in these square root functions. So let's take that and let's go to Desmos here, and we're going to graph some of these. So the first one we're going to graph is we're going to graph square root function, okay? So I got everything typed in. I'm just going to hit that. All right, and so this is what the square root function looks like. And if you pan out, you can see it's not very exciting. They take a long time to grow, right? They will grow, and over time they will get big, but we're talking infinite amount of time, right, for them to get large. You look at them like up close, like they get really big really fast, and then they flatten out, right? And they start to represent like a low curve. So with these, right, the part that's interesting is if you look at this, you see that if we look at this point, it starts, you got 0, 0, right? You got 1, 1, right? Where it goes right here, and then here's another point. That's a familiar point, right? I don't know why it's doing that. It should put me on 4, 2, not these nonsense points, right? But we got the point 4, 2. Here's 9, 3. The next one should be 16, 4, right? And we have 25, 5 is where it actually hits the 5 mark before it breaks it. So we're seeing that this is the absolute opposite of what a quadratic would be, right? And it is reflected over what a quadratic function would reflect. The difference is, though, that you can't put a negative number into a square root function, because even though we've talked about like i's and things like that and imaginary numbers, that doesn't really fly with graphing, because we don't really have the tools we need to know to how to graph this, that it's going to make any sense to us, right? So the domain of these is it can't be anything smaller than 0. It can go in this, right? And then our range, right, is we don't get anything smaller than 0, because you can't get a negative value when you take a square root of something. It's just you're not going to get it, right? Because even though you can definitely have that happen, but it doesn't make sense and doesn't understand it, right? So we are going to graph this now, okay? And so we will go back to our thing here, right? And so we're going to take our pen tool, and we are going to take this, and we start right here, and it kind of goes like this, and then it starts to flatten out, and it goes like that, right? And then put a dot here, and so this is the point 0, 0, right? And it's important to kind of note that that's where it starts, right? So our domain is going to be, and what we'll do is we'll go like this. We'll go x, and for all x is greater than or equal to 0, right? And that's going to be our domain. And then our range is going to be kind of similar for all y. Y is also greater than or equal to 0 in this case. Okay? So that's what we got for our square root functions. Let's head back to Desmos and do our cube root functions now. So we're going to toggle this one off and toggle the cube root one on. And this one is really interesting, right? This is a lot more interesting. You look at this, it looks kind of a lot like the square root function, except that this has a negative component. And the reason this has a negative component is because if you can have negative numbers for cube roots, because you can take a cube root of a negative number. If you have -8, the cube root of it's -2. In fact, you'll probably find it if you look here, right? If you put in -8 for your x, right? Right here, you go down and you get -2, right? Sorry, I had it the first time. Yeah, there you go, right? So it does work. And then it's 0, 0 is kind of like this turning point, sort of an inflection point, if you will, where the graph changes, goes from positive to negative, and it kind of almost looks like it does like a rotation, right? Like it rotates 180 degrees that way. So that's kind of interesting to note. So let's go back and let's draw this thing. All right, so wrong way. Here we go. Okay, so now this one we get something and it's going to look kind of like, you know, like the same. It's going to go this way, except that now it's going to come down and then we're going to go like this, right? And so that point like sort of makes sort of like a pinwheel looking thing, right? That point is the point 0, 0. All right. In our domain, there's really nothing you can't put in this. So we like this one because this is our good friend, all real numbers, right? All real numbers. And then our range is also going to be all real numbers because you can get any positive or any negative value. You have to put in a huge or very small x value to get that, but you can get it, right? So I hope this is kind of I hope this is interesting to you, kind of making you think a little bit, right? And it's kind of, if you think about the relationship between even and odd functions, well, it's the kind of the same thing with even and odd roots, right? The way it's going to work, you get more constraints with the evens than you do with the odds, right? So square root's an even root, the cube root would be an odd root, right? So we are going to stop the video here, and then we will pick up and do a bunch more of these and just kind of have some fun with this. All right.